Well, hello once again. We're going to start this video out by using our brand new LCR meter that was sent to me by our good subscriber Ron C, the model DE5000. I haven't had a chance to use it yet, but we're going to use it today because we're going to test the coil that came out of our radio chassis. It's supposed to read 100 microhenries. Coils are measured in henries. Just like capacitors are measured in farads and resistors are measured in ohms, coils are measured in henries. But in order to test it, I need to first calibrate the meter. It requires a calibration, which means that I'm going to go ahead and turn it on, and then I'm going to go ahead and hit the cal button for a few seconds, and then the screen's going to light up and it's going to say open. And what that means is these two connectors will not be touching. They'll be open, and then it'll go through a 30-second check, and then it'll say passed or failed. Now once that's done, then I have to connect the two leads together and run a second test for 30 seconds. It'll say shorted up here. It won't say the whole word. I think it's SRT or something like that for shorted, meaning that these two leads are connected together. Then we'll run another 30-second cal test, and once it gets through the cal test, then we'll go ahead and find out if that passes. If it does, then we'll disconnect the two leads, hook them up to our coil, and do a readout. So let's get started on that. All right, here we go. I'm going to go ahead and hit the power. She comes on. This thing defaults to auto mode. See if I can get a little close up on the screen. See, it defaults to an auto mode right there. So what we're going to have to do is we're going to have to hold the cal button in. Right now we're on L for inductor. Okay, it's either L, C, or R. L is for inductor. We'll go ahead and hit the cal mode. And there it is right there. It says open. If I get this light to stop glaring on this screen, it says open, which means the two leads are open. Now we hit cal again, and it'll run through a 30-second test. Do a little countdown for us here. I'm not going to do the test where they're shorted together. There's no sense in wasting an entire minute on this. I just want you to see what happens after 30 seconds with it open. And we'll get the same thing after it closed, after the two leads are connected or shorted. We hope. Let's let her count down. Come on, baby. There you go. It passed. All right. I'm going to connect them together and run it through another test. All right. Here it is. I'm finishing up the short test. And I have another pass. That's good. The coil is connected. And I'm still sitting in the short mode. It showed that I passed. Now I'm going to hit this LCR auto. And hopefully the L will light up and it'll tell us what henries we have here. If not, I'll press it again and again and again until finally I get the inductor symbol to light. So here goes. Well, maybe I didn't hold it long enough. Let me hit cal again. Maybe I got to get rid of that first, huh? Yeah, that's what I got to do. Okay, you have to hit cal again. And it is right now in the resistance mode, the R. I'm going to have to go to L. Let me go ahead and hit the blue button again. There it is, L. It's now been calibrated. The coil's hooked up. And I'm reading 104.4 microhenries. See it right there? Microhenries. 104.4. That's not bad. That's only 4.4% out of tolerance. I can live with that. You know, we're going to go ahead and use this again. I don't need to buy another one. Now, I was going to go ahead and clean this baby up, but there's really no need. Let me go ahead and shut this off. By the way, the hardest thing on this thing is these alligator clips. Boy, they are really rough, man. You got to squeeze your brains out to get that wire to get them to open up so you get the wire in. You can't even hardly get it out, man. Okay. Now, if you look real close here, you can see that whole thing is not the coil. Just the center part is. See the reddish part? That's your coil. And what they did was wrap it around and around and around with sort of like a cloth tape. and then they put the beeswax over the top. So that's your actual coil. Well, this coil's good. We're going to go ahead and use it again. Now I may dress it up a little bit. I may put some liquid tape over the top. You know, it doesn't matter, because once these coils open up, that's it. It's over and done with. There's nothing you can do with them. And they're a dime a dozen on eBay, so it's no problem. I may go ahead and put liquid tape over the top. I may find a big piece of heat shrink and shrink down. I don't know. We'll see. I won't shrink it down tight. It'll be just barely shrink it, because I don't want to damage this thing any more than it already is. Just pretty brittle wires. I also may run some heat shrink up the wires, or attach on with brand new wires, maybe right here, cut them both to the same length. You got to kind of make a call. You know, you got to make a judgment call. You just got to make a decision about what you want to do. Well, now that the coil business is done, what's next? What should we do next? All right, I've decided to kind of do a cursory layout of the terminal strips. You'll remember in the last video I told you that you're pretty much on your own when it comes to where you should put these things, you know, where to position them and how to hook up the wires. You got to kind of figure it out. It's like a little puzzle, you know. And what I'm going to do right now is to go over this schematic, looking at all the green capacitors, and try to figure out if any of them can be run through the same holes. Because right now I have 2, 4, 6, 8 holes that I can use, 2 in each one, okay? And if I have 9 capacitors, but I have, you know, 8 holes. It would be nice if I could find 2 capacitors whose leads are connected to the same point that I could just run through one of the holes. That would give me enough holes left over in the terminal strip to go ahead and solder the rest of the capacitors. So let me take a look at the schematic and I'll get back with you. Well, we got really lucky. We got really lucky. Look at what we've got right here. Let's zoom in here. We have 3 green capacitors here. 1, 2, 3. And you'll look at this line coming off. Now this comes off the screen grid of the 24 tube, which is the AVC tube. One side of the cap comes up, comes over, comes down. It connects to one side of this cap and one side of this cap. I can connect all 3 of those together on one lead. Now, of course, the other lead goes wherever it's going to go. We're going to go this way, going to go this way. But these 3, 1, 2, 3, are all the same electrical point. Remember electrical points now that I talked to you earlier. Let's see if I have any more. Yes, I do. Right here. I've got one side of a capacitor. It comes down and connects to another side of a capacitor. Both the same electrical point. And once again, the other side goes wherever it's going to go. All the other ones are kind of standalone. You know, this one doesn't connect to anything. Okay, it just sort of stands all by itself out there. And this one over here kind of stands all by itself. It's not connected to any other capacitor. But that's pretty darn good. And this one right here. Let me see if this one connects anywhere. Goes here. Where is it? There we go. Goes here. Goes up. Nope. Nope, nope. That's another little standalone cap. So we've got 3 here. 1, 2, 3. And 2 here. Oh, that makes things a whole lot easier, okay? We now have enough holes in 2 terminal strips that we can mount those caps. And let's take a look at where we're going to put them. I made another command decision. I have decided to salvage the box and reuse it. And, you know, it's just for, you know, sentimental purposes. That box has been in there for 80-some years. Why leave it out now, right? But I have to make a determination. You know, this is the largest capacitor I'll be using. And I have to kind of, we're looking to get it between this hole right here where the you know, the thing is mounted, and down here in this hole where the box is mounted. So we're going to be putting these terminal strips in, one about right here like this in the center, so it clears the sides of the box. And then we're going to put another one over here somewhere to where it clears the side of the box. And then we're going to run the capacitors across between the 2, and this is my largest one. So what I'm going to do is I'm going to go ahead and kind of sort of position this the best I can and mark it with a pencil on both sides and the top, so I have a kind of an idea where I want to put it. Well, there it is. That's the approximate position that I'll be putting the large capacitor in, or all of the capacitors. The rest of them will fall within the left and right line because they're a lot smaller in size, physical size that is, and value of course. So that kind of gives me an idea. It's not perfect, but we'll see. Now the terminal strips will go right about here. I'm going to move that. I think that bottom piece right down there, that fastening tab, will probably, I'll turn it to the inside where I have more room, to maneuver them this way. And I'll also turn the other one around this way, so the tab again, the grounding tab is on the inside, so I have more maneuvering ability here too. You don't need the tab hitting the sides of the can, okay? Okay, now the next thing you have to figure out before you do anything is where you're going to drill your holes. I will have to drill holes for this. And you don't want to be drilling through here that might drill into something that you don't want to be drilling into, or make it so whatever the item on top of the chassis might not fit well. The chances are pretty small because I'm going to go with a screw from the top of the chassis down, into the bottom of the chassis. And it's just a little old rounded screw head, but you never know. It's always best to take a look. So let's do that. Now here are the existing screws right here, the holes that the can was fastened with, and it's going to be right underneath where the tuner fits. These are the 3 tuner hole legs. The tuner will fit right there on top of that. So we'll be drilling our hole, somewhere in here and somewhere in here. Shouldn't be any interference whatsoever. Nothing else goes there. It's an open space, okay? Alright, we're going to make this a really short video this time because I have to drill the holes and get things set up for the capacitors. Now keep one more thing in mind anytime you do something of this sort where you're going to mount things on a terminal strip or between 2 terminal strips or whatever the case may be. You may, figure it all out, everything's great, you go to put it together and all of a sudden you say, geez, I don't have enough room there to put all those capacitors on there. I thought I did, but I don't. Well, what do I do now? Well, you just kind of adapt and overcome, you just kind of be flexible. You mount your capacitors outside or away from the terminal strips over here where you get a clear area. That's what I plan to do. If I find that this capacitor is so big, along with the other capacitors, because I do have another one that's that big too, if I find out that they all won't fit under that box, and I may even have to wind up modifying the box. Right now I'm thinking about a modification to that box. But hopefully I won't have to. But if I do, I will do it. I will do it. But if I find that they all don't fit underneath there, no problem. I'll just run it out. Look at all the space I got up here. I can mount capacitors. I got all kinds of space here. There's even more probably. Let me see. There's even some space down here. Over in here I got a lot of space, There's plenty of places where we can do that. Don't worry about it. If you have to mount a capacitor elsewhere, do it. Not the end of the world. Anyway, that's where we're at right now. Next time I'll have the holes bored, and I hope to have the terminal strips mounted. So until next time, this is John.